Hello everyone, welcome to my channel. In this video, we will study about impulse turbine. Impulse turbine. Impulse turbine is defined as the turbine in which high velocity jets of water or steam hits the blade of turbine to rotate the turbine and produce electricity using this rotation. The impulse turbine is named so because it acts on the impulsive force created during the striking of water jet to turbine blades. In the impulse turbine, water strikes the blade tangentially, so it is also known as tangential flow turbine. The impulse turbine are suited for high head and low discharge of water. It means it has used when volume of water flow is low and there is high pressure due to high location of water head. In impulse turbine, kinetic energy of high velocity water jets coming from nozzle are converted into turbine shaft work. The blades of impulse turbine are usually of bucket shape. Components of impulse turbine. Penstock. The penstock is a channel or a pipe for conveying water to impulse turbine. The water at the high head is brought to the turbine using this penstock. The penstock is connected to water reservoir. The water reservoir is normally located several meters high. Nozzle. The nozzle is used to increase kinetic energy of water and sprays the water to the blades of turbine. This nozzle creates a jet with high velocity. It points the flow of water towards the blade in a particular direction. In an impulse turbine, single or multi-nozzle can be used. Runner. The runner is a circular disc mounted on a rotating shaft. This rotating shaft is known as rotor. On the runner, cup-shaped blades also which are evenly shaped are mounted. Cup-shaped blades are also known as buckets are mounted on the runner. These buckets are mounted in such a way that these buckets are evenly spaced. Buckets. Buckets are cupped or spoon-shaped blades of turbine. The buckets are mounted around the periphery of the runner so that when pressurized fluid hits the bucket will receive the momentum from the fluid and helps the runner to rotate using the fluid momentum. Casing. In an impulse turbine, a casing is used to stop the splashing of water and guide it to the spillway so that there is no wastage of water. This casing is also used to protect the components from external environment. The casing is generally made up of cast iron. Braking jet. A braking jet is used to stop the turbine blades after supply of water from the nozzle is stopped. Turbine blades continue to rotate even after water supply from nozzle is stopped due to inertia. Hence, the braking jet is hit on the opposite side of a turbine blades to support and stop the blades from rotating instantly. Working of impulse turbine. The water at the reservoir has potential energy due to its high location with respect to the nozzle. This potential energy is converted into kinetic energy by letting the water flow through the penstock and then comes out at high pressure through nozzle. Inside the nozzle, there is a spear-like arrangement that can be loosened and tightened to control the flow rate of water. When the water jet from nozzle strikes the curved surface of bucket, it imparts its energy to the bucket which results in the rotation of the bucket. Due to curvature of the direction of the water jet, is almost reversed to absorb the maximum force from the water jet. The reversal is about 165 degrees. The flow rate of water controlled at the nozzle helps in determining the speed and power generated at the rotor. The rotor is connected to a shaft, and this shaft is connected to gearbox that modulates and transmits the power to generator at a specific speed. This generator produces the electricity at the required frequency. The water, after getting deflected from the bucket, flows through a path called tail race and exits the turbine. Types of impulse turbine. Pelton wheel turbine. The Pelton wheel turbine is most famous type of impulse turbine. Each bucket used in this type of turbine have double cups with a splitter between the cups. The water jet hits the splitter between the cups in the Pelton turbine, and hence the efficiency of turbine is increased. Pelton turbine can achieve efficiency up to 95% and up to 90% efficiency is achievable in microscale hydropower plant. Turbo turbine. Turbo turbine is the impulse turbine that is most suitable for medium head operations. The bucket used in the turbo turbine have single cups, and the cups are more shallow. Unlike the Pelton turbine, the water jet hits the bucket obliquely about 20 degrees in the turbo turbine. Cross flow turbine. Cross flow turbines are modified form of impulse turbine mainly used in small hydropower plants. Cross flow turbine was developed by Michael, Donat and Fritz in 1903. They are easy to fabricate and need very little maintenance. In cross flow turbines, the water passes through the turbine transversely or across the turbine blades, unlike the other turbines where the water flows axially or radially. Now, let's see some advantages and disadvantages of impulse turbine. First, let's see advantage. This turbine has high efficiency. This turbine can work easily at low discharge. It is very easy to assemble. This turbine can be adjusted according to flow rate conditions. At high flow rate, multiple nozzles are used, and at low flow rate, single nozzle is used. Now, moving to disadvantages, it is very costly to install. Its efficiency decreases with time. The size of this turbine is large as compared to other types. This turbine works only in high head, which is difficult to control.
So, guys, that's all for today. For more such videos, please like, share, and subscribe to our channel.